Hello, today I'm going to be talking about Ohm's law and Watt's law. I'm going to start with Ohm's. Okay. Ohm states that current through a conductor between 2 points is directly proportional to the voltage across the 2 points. Introducing the constant of proportionality, the resistance, thus mathematical equation I equals V over R, where I equals current, V equals voltage, and R equals resistance. Now let's go to my drawing over here. This is my drawing for my Audi. It is my car stereo system. Okay, I have a 12 volt battery system, negative and positive. My current flows this way. As you can see, and my CD player is included in there, which has barely to no resistance. Okay, I have a 4 ohm resistor, which is actually my speaker. So to solve this today, what I'm going to be doing is, this is the triangle of Ohm's law. I like to solve it by whatever you're solving it for, you place your finger over it. And today we're going to be looking for how many amps or current. So if we're given the volts and the resistance, we need the current. So hold your finger over I, so it leaves you with V over R. So then you'd have to divide V divided by R. So you take your volts divided by your resistance, 12 volt divided by 4 ohm, which means 3 amps of current. Okay, now I'm going to be moving on to a little bit more about Ohm systems. Okay, Ohm's law is true for any circuit that has resistive elements for all forms of driving voltage and current, whether it's AC or DC. Although Ohm's law will not apply in impedances that contain inductance or capacitance. I is the current measured in amps and the resistance is measured in ohms. V is voltage measured in voltage. And another way to explain this would be, if you're solving for current, you'd take volts divided by resistance, which is I equals V divided by R. You're solving for resistance, your volts divided by current. If you're solving for volts, what we showed up here, or no, I didn't show that up there, current multiplied by resistance, that if we were solving for volts. Now I'm going to be moving on to the Watt project. Okay, this is a common breaker in the house. It's a 15 amp with 110. If I'm solving for to get my which gives me 41.25 bulbs. Well, obviously we can't use a quarter of a bulb, so we're going to back that off to 41 bulbs. And then that's going to leave me with 10 watts to spare. And now we're going to talk a little bit more about the Watt project. The watt is derived unit of power in the International System of Units. It's named after James Watt. The unit is defined as joule per second and can be used to express the rate of energy conversation to transfer with respect to time. Okay, now I want to talk a little bit more about James Watt. He also created the steam engine. This was one wise man. If it wasn't for him, we wouldn't have been able to find out a lot of things. The steam engine was actually responsible for a lot of people's way of lives and livelihood. So I'm going to be